taking a bit to start up. All right, and we're recording. Please go ahead, Eric. You're muted.
All right, there we go. Hello, everybody. So my name is Derek Parker. I am the original author and still maintainer of the Delve Debugger for the Go programming language. So in this morning's session, I wanted to keep things pretty light and loose. I have like a little bit of material to go over up front, but I really wanted to keep it deliberately loose so that the folks on the call can kind of drive the conversation to where like the things that you all would like to see and questions that you have and everything like that. So I'll spend a little bit of time going over basics and then I'll let the kind of conversation dictate where we go next. So I apologize in advance if there's any noise or anything like that in the background. My children are home from daycare for the week. And I apologize if I'm a little bit slow on the uptake on anything. My 1-year-old did not let me sleep last night. So fair word of warning for everybody. So I'll go ahead and share my screen. I just kind of wanted to go through like some initial examples of how to use the debugger, go through how to kind of get help using it and stuff like that. And then, like I said, I'll kind of let the questions in the conversation guide where we go next a little bit. So I'll show a few basic examples of starting up the debugger and in different ways. And one particular way that I think is applicable to most folks here that I think is also really cool that a lot of people might not know about. So without further ado, let's dig in. So let me share my screen real quick. Okay. Rearrange some windows. Okay. Let me. All right. Can everybody see that okay? And the font size is all right?
Yes.
Okay. Perfect.
Yep.
Great. So the first thing that I want to go through is a couple examples of just how to start up the debugger. Now, when I was talking to Brent, we were talking about like how to do this all within the context of Podman. So I'm within a little Podman container right now just to have a consistent environment. So I'll show a few examples of just how to get started with Delve. So in my opinion, by far the easiest way to get started, especially within the context of Podman, is to use the Delve Debug subcommand. Now, if you just type DLV help, like in any common CLI application, you'll get a bunch of information. And so from the command line, we have a bunch of different commands that we can use. So you can attach to a running process. You can connect to a headless debug server that you have running. So this could be useful for if you're trying to debug something on a remote server or remotely from like you're outside of the container and you want to debug something in the container. You can start like a headless debug server and connect to it from wherever you want. I can show a little bit of an example of that if folks want. You can do core dump debugging with Delve. Some of the commands you don't really need to use too much, like DAP is more for integrating with like IDEs and stuff like that. It's the debug adapter protocol server. So debug is the command that I'm going to show next. But you can also execute a precompiled binary. you can replay an RR recording trace. I'll go over a little bit what that means in a second, but it's a really, really cool feature. So this run command is deprecated. This was around since like the origins of Delve. It's been deprecated for a while. We've just never removed it, but it was replaced by debug. There's the test subcommand, which allows you to basically, like, if you're trying to debug a library, so like this would be applicable for Podman as well. So if you don't want to start a debug session from like the from the the main like command line binary that you produce, so that would be like under the CMD directory and then Podman. So the binary that's produced out of that package, that main package, if you don't necessarily want to debug that directly, but maybe you're working on a feature, there's something going wrong with it, you have a test written around it that is failing or something like that, or is somehow exhibiting the bug. If you use this test subcommand, what Delve will actually do is it can compile a test program for you using certain flags that it uses to disable optimizations, and I'll talk about that in a second as well. But it allows you to debug a test binary. So if you're trying to debug something within like the library code of Podman or something like that, and like I said, you don't want to go through like invoking the entire like Podman CLI or something like that. You can use this as a way to start a debug session from a test, and that's, I've used that a ton. It's something that I use all the time, in fact, and so very, very useful little feature. The last useful command is trace. So Delve has a mode where you can essentially like do kind of like a user space strace type thing, where you can trace arbitrary functions in your program as your program is executing. So it doesn't really start like a full interactive debug session. It's kind of like strace, where you're just spying on your program. And it has two modes. There's a default mode, which uses ptrace under the hood. And then there's another mode that I'm still kind of working on developing to get parity with the ptrace mode, which uses eBPF underneath the hood, which is significantly more performant than using ptrace. I won't go into the details of that, but just something that I kind of wanted to mention. So with all of these subcommands in mind, I wanted to talk about using the Delve debug command. So this is the one where if you want to debug the CLI, this is what you'll do. And so from the root of the project, so I'm just in the root of the Podman repository. What you can do it in two ways. So if you're at the root of the project, you can say Delve debug and then supply it a local package path. Now, what it wants in this context is a main package, because what this subcommand is going to be doing for you underneath the hood is it's actually going to compile this main package for you. And Delve supplies a few flags to the Go compiler, which I'll share in the chat what these flags are. But essentially what they do is they disable optimizations from the Go compiler during compilation. Now, this is beneficial because while debugging optimized binaries has gotten a lot better, both on the Delve side and from the Go side, there's still certain things that might not work correctly when you're debugging an optimized binary. For example, by default, the Go compiler does like inlining of functions, some dead code elimination, and registerization of variables, and all of this stuff. And sometimes the compiler doesn't translate these optimizations very well using the dwarf debug information that's stored in the binary. So it makes the binary potentially difficult to debug when, say, like a function is completely eliminated that you expect it to be there, or like you can't find the value of a variable or something like that because the debug information isn't isn't exactly lined up with the optimizations that the compiler performed. So again, this situation has gotten a lot better in recent years due to work upstream in the Go compiler and some interesting workarounds that we put into the debugger. But it's worth noting, right? So when you use this subcommand, you don't have to worry about that. Delve will compile the package for you, and the resulting binary will be ideal for starting a debug session against. So you don't have to worry about any of those optimizations and stuff like that if you do it this way. If you compile yourself, I can talk about the flags that you can pass along to produce a better binary that's more suitable for debugging. So with all that said, with just this command, Delve will compile the program, run it, attach to it, and start a debug session. So I'll let that happen. And now we're at the prompt. So you can type help for a list of commands. So where we are right now is, as I mentioned, the debug session has just started. So we're at the very, 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 very like beginning entry point of the program. Like literally the first CPU instruction that's going to be executed when the program starts. So that fact is sometimes surprising to folks. So if you're following along, Daniel posted something in the chat. You'll probably need to prefix it with a dot. So DLV debug /command podman so that it knows that it's local. Otherwise, it's going to look for the package path elsewhere, like in the vendor directory of the current module that you're in or something like that. And I did see the earlier chat message about some Starlark examples. I can definitely go over some of that stuff as well. Okay, so so like I said, we're at the very beginning. So that's something that confuses people a little bit, where maybe you would expect to be like at the main function or something like that. And this is something that we've talked about a lot upstream about if we should fast forward folks to like a part in their program that is a little bit more familiar, like the main function or something like that. But we don't want to fast forward you past any of the init functions that you might want to debug or any of the program startup code. We don't want to make those assumptions for you. So when you run this command, you're literally at the very, very entry point of your program. You can even see a little bit like, we're stopped at some random address. There's no source available for it. So we don't have a ton of information to go off of right now, but we'll fix that. So the first thing that I did when I jumped in this session was I typed help. Now, there's also something else that maybe might be useful. Let me run this command real quick. So this command is really just Delve allows you to create a transcript of your debug session. So I'm going to essentially what it'll do is it'll put all of the output from what we're doing right now into a text file. So I can upload this somewhere after the call if anybody wants to go through and look back at like any of the specific commands that were used or anything like that. I want to go through the help output a little bit just to give some context to it. It's pretty self-explanatory, but I want to give a little bit of context to it and just show everybody what's available to you within a debug session, and then we'll go into some of the specifics of a few commands. So the command help output is broken down by categories, right? So you have all the commands to manipulate running the program, all commands to manipulate breakpoints, everything to view program variables in memory, so on and so forth, right? What Delve, like the whole philosophy behind Delve is really trying to keep things as simple as possible. So trying to be as useful and powerful a tool as it possibly can, while staying out of your way as much as it can as well. So a lot of the things are pretty basic to use, but once you master them, you can do a lot of like really, really interesting stuff. And all of these commands, at the end of the day, one of the things that I really like to, like, when I talk to people about debugging or using a debugger or anything like that, like, using the tool and knowing how to use the tool is half the battle. But what I really like to talk about when I talk about debugging or any of this kind of stuff is like the mindset that you should be in while you're debugging your program. I think the mindset that you're in is as important as your knowledge of the tools that you can use. And the mindset that I think you should be in is ask questions, right? That's really what you're doing when you're debugging. You're asking questions. You're like forming a hypothesis in your head of what you think the problem might be, and then you're asking questions, gathering data to either prove or disprove that hypothesis, and then you rinse and repeat, right? It's kind of like the scientific method. We want to ask questions, we want to get data, and then we want to use that data to inform our next move and tell us where to go. So a lot of the commands that are available to you are there to ask and answer these questions, right? Like, what is my program doing right now? What is the value of this variable? What happens when I change this, right? Like, all of these, this is what you should be doing: asking questions, getting answers back, and then using that to inform your next step. So be kind of cognizant of the mindset that you're in when you're trying to debug something. So I want to go through the commands a little bit real quick. So the first set of commands we have is to run the program. So the first command that we have here is call. So this allows you to call a function within the program that you're debugging from the debugger. Now, this is still, it's marked as experimental. It's pretty stable in AMD 64, so x86 64. We just got support merged in for ARM 64 upstream. So this particular command involves, like, we need coordination from the Go runtime. So Delve is actually, there's other debuggers that you can use with Go and stuff like that. Delve has become the de facto over GDB and such. But Delve is the only debugger that can call functions in Go program. And that's because it requires some coordination with the runtime. So myself, the other Delve maintainers, work pretty closely, very closely with the upstream Go runtime team and stuff like that. So we're able to kind of bridge these gaps and work on some really cool features together. So you can call a function in a Go program. Right now, it's only limited to AMD 64. But like I said, we have ARM 64 support coming with Go 19 and the next version of Delve. So that'll be available pretty soon. The next command is continue. So this is something that you'll be using all the time. It allows you to continue the program, essentially. So you run until the next breakpoint or until the program terminates. There's also some cool stuff you can do with continue that I'll show off in a second. So next allows you to step over to the next source line, and it steps over functions. So it won't step into a function call, it'll just step over it to the next source line. Rebuild allows you to recompile the executable and then restart it. So this only works if the executable was built by Delve in the first place. You can restart the program without recompiling it. You can step, which will step to the next line, but it'll also step into a function. I can show that a little bit as well. You can single step CPU instructions, and you can step out of the function context that you're in right now. And then I won't go through everything, the rest of the commands, like one by one. I kind of want to leave time for question and answers and stuff like that. But there's a whole section for manipulating breakpoints. You can set breakpoints, list them, clear them. Some interesting stuff is you can set conditions on breakpoints. So you can say, like, I want to set this breakpoint, but I only want it to be triggered if the value of this variable equals 5 or something like that. So I can show off the syntax for it a little bit, but essentially Delve has a built-in expression parser. So you basically give it an expression that would evaluate to a Boolean condition. and then that expression is evaluated within the context of where we stop when we hit that breakpoint. And if that expression evaluates to true, the breakpoint is triggered. If it evaluates to false, we skip that breakpoint and continue going. There's also the on command, which allows you to basically assign like behavior to breakpoints. So you can say like anytime this breakpoint is hit, print a stack trace, or anytime this breakpoint is hit, print the value of this variable, or list all of the Go routines, or whatever. Basically, any normal command that you can run within Delve, you can have run anytime a breakpoint is hit. Toggle self-explanatory. Toggle on and off breakpoint. You can set a trace point within a debug session. So this is like set like doing the trace command from the command line. It sets a pseudo breakpoint like where you'll get some output whenever this trace point is hit, but the program won't stop for you to issue like interactive commands and stuff like that. And then you can also set watch points. So watch points, I think, are really, really cool, underused, and I think they're underused because a lot of folks don't really know about them as much, who don't have a lot of experience with debuggers. You're more familiar with breakpoints and those kind of things. So watch points are really cool. So a watch point is useful for, like, say for example, there's a bug where like some mutable state is getting mutated somewhere, and you're not exactly sure where that's happening, like where this memory is being modified at, or like maybe you're passing around a pointer and it's being changed somewhere, but you're not exactly sure where it's being changed. The watch command is really cool, where you can say, I want to watch this variable, this memory address, and I want you to stop the program anytime this variable is written to, so anytime it's modified, or anytime it's read. So it's a really cool way to like let the computer do the work for you. That's another thing, is like let these tools do a lot of the work for you, right? Like if you're not sure where something is changed, where the value of a variable is being changed or something like that, just ask. Ask that question, where is this being changed? Continue your program, and then let the answers kind of guide you to where you're going next, and let the computer, let the tools do the work for you. So the next section is about viewing program variables in memory. So there's some kind of useful convenience commands. So args will display all of the arguments to the current function that you're in. Display will basically tell Delve, like, anytime the program stops, print the value of an expression. So if you find yourself like repeating a command, or like trying like printing out the value of a variable like every time you issue a command or something like that, this is just kind of a convenient way to have that done automatically for you. You can examine raw memory with examine mem. There's a bunch of like different flags that you can use to modify that command, but you can just see like raw memory at a given address. You can print all the local variables. You can print using the print command. You can print the value of a variable, but it also can evaluate an expression. So you can check like equality and do all kinds of interesting stuff with that. Regs allows you to get the contents of CPU registers. Set allows you to change the value of a variable. So again, that's like going back to, asking the question of like, what happens if this is this, right? Or what happens if I change this, or whatever, asking questions. So you can ask that question and change the value of a variable, and then continue your program and see what happens. Vars will print out all package variables. So this is like all global exported variables in your program, essentially. And what is will print the type of an expression. And this being a Go debugger, obviously we have facilities for being able to list Go routines and stuff like that. So if you just do the Go routines command with an S at the end, it'll list all Go routines running in the program. If you do Go routine singular, you can get information about a particular Go routine. The the particular Go routine that you're running on right now, or you can change your current like debug context to a different Go routine. So if your context is on whatever Go routine 3 and something interesting is happening on Go routine 5 that you want to check out, you can switch your context over to that Go routine and start continuing on the debug session from there. And then you can do the similar thing with threads. You can list all threads and you can switch your context to a specific thread. I can go over some of these commands a little bit later as well. But you can also view the call stack and stack frames and stuff like that. So the first command here, deferred, allows you to execute a command in the context of a deferred call. So this is important because Delve will actually make sure that you are in the context of a deferred call. So if you defer a call to a function and that function is just called normally, like not as part of a defer statement or anything like that, then that breakpoint that Delve sets internally won't be triggered. This is always within the context of an actual deferred call. So if you need to check out something that's happening in any defers that you set up or anything like that, this is a good way to do that. You can move up and down the stack frame with up and down here. Frame will set the current frame or execute a command on a different frame. And stack will print the stack trace and give you some information about the stack frame. So I'll go over some of these commands a little bit as well. And then we have some miscellaneous ones. So there's some configuration that you can change within Delve. You can show like you can do like disassembly of functions and stuff like that and see the actual CPU instructions. You can create a code dump at runtime from the current process state while you're in a debug session. You can list the functions, list shared libraries, list source code, see all of the source code that's in the binary, source Delve script commands, and print a list of types. So there's a lot of stuff that you can do, but you should find that most of it's pretty self-explanatory and easy to use. And then, like I said, as you dig into some of these commands, there's flags and different things that you can do to modify their behavior to get some more advanced stuff happening. So with that in mind, let's kind of play around a little bit. So the first thing that I want to do is just continue somewhere. So there's two ways that you can do it. You can set a breakpoint, or if it's just like a temporary breakpoint, you just want to continue like to the main function or something like that. What I like to do is just type continue, and then just continue to where you want to go. So this continue command takes an argument, and it'll set a temporary breakpoint and continue there. So you can do something like continue to main.main. And another cool feature is there's like fuzzy prefix searching and stuff like that. So you can actually like fuzzy search locations and stuff like that. So for example, if I just type continue mama and hit tab, it'll fuzzy search to main, which is the main function that you write in your main package. So if we continue there, you can see we get some output. You can kind of ignore that. But you can see right here, like it's setting a breakpoint for us. This is an internal breakpoint. So if we list all of the breakpoints, it's not going to be there anymore. It's just a temporary breakpoint that's set as a convenience. Now you will notice that there are some breakpoints set for us already. So by default, Delve will set breakpoints for runtime fatal throw and an unrecovered panic. So if your program panics or if the runtime throws at any point during the execution of your program, Delve will stop the program before it fully unwinds and terminates, and lets you kind of dig in that moment and see what caused the panic and try to debug in that moment before all of the state is lost and the program has exited. So that's why these are set by default. So that's just like a nice convenient way of continuing to a location. Obviously, we can use next to go to a different line. You can use step to step into a function. So now we're within a function instead of stepping over it. And then you can use step out to step out back to where we were before. And then if you continue, you'll go all the way to the end. And then you'll see like we're just getting the help output because we didn't supply any commands, right? So there's with the restart command, you can change the argument vector that's passed to the program when it runs. So we can say like restart, and it's as if you're calling it from the command line at this point. So pretend you're just calling Podman or whatever. So you can say restart version, right? So now if we continue, we'll see we get the version output from Podman. So we've just changed essentially the argument that we like how the binary that we compiled is being called, the command line arguments and stuff like that are being passed to it. So this is really interesting and really powerful for like if you you're in a debug session and you don't want to like get out of the debug session and restart it or whatever. You can just restart the program and supply it different arguments if you need to test something else or go down a different path or something like that. So that's the main way to kind of get started. I've also precompiled Podman here, or at least I thought I did. Anyway, so if it's precompiled, I won't sit here and run make all and watch and have everybody watch that. But you can use a delve exec subcommand. So if you had like bin Podman already created, you can use the delve exec subcommand to execute a pre-existing binary. Now, I'll put in the chat real quick. If you are building binaries yourself, you'll want to pass along this. So and that's during the like go build invocation, right? So basically what that does is that tells the Go compiler to disable a lot of the optimizations that it does by default, and produces a binary that's a little bit more suited for debugging, and you won't run into any kind of weird issues in terms of like inlining functions or anything like that. So one other cool thing that I want to show kind of just off the cuff a little bit before I start kind of like getting into questions and like what else people really want to see. So I assume that we're all running on Linux, and I assume that most people are running on like an x86 64 processor. So if all of these things are true, and even in some situations where they're not, but we can do this really cool technique of debugging where it's called record replay debugging. Now, this might be useful for a lot of you folks. I know I get a ton of use on it out of it whenever I'm able to use it. So Delve has the ability to use like different backends. So we have a native backend that we've written. We also can integrate with LLDB. It just makes things easier on certain platforms like Mac OS X. And then one of the other backends that we can integrate with is the Mozilla RR time traveling debugger. So when we communicate with a backend, Delve is still doing all of the heavy lifting when it comes to the logic and all of the Go specific things. We just use these backends sometimes to do some of the low level heavy lifting. And now that's not always true. Like I said, Delve has its own native backend that does it's a fully functional debugging backend. But to be able to use some interesting features from other tools, we're able to kind of integrate with them. And one of them is the Mozilla RR debugger. So if you're not super familiar with it, it's a time traveling debugger that Delve is able to take advantage of, where you can essentially record the execution of a program, and then you save that in like a trace file, like a recording, and you can go back and debug that recording an infinite number of times. And every time you go back and debug that recording, everything is going to happen exactly the same. So this is really cool for like a couple. I use this in a few different situations personally. The first situation that I use is, say you have a bug that only shows itself like 1 out of every 50 times that you run the program or something like that. If you can capture the bug that 1 time out of 50 and record it, then as long as you have that recording, you can trigger that bug each and every single time you replay it, right? So it cuts out the time of debugging, like, Heisenbugs or like flickering tests and that kind of stuff, where if you can capture and record it once, you can debug that same execution endlessly. You'll always be able to trigger that bug and see it, and it'll help you get to root cause analysis a lot quicker. Another cool usage for this is, say you're trying to debug something, but you're stumped, like you just can't figure it out, and you need the help of a colleague or something like that. If you have this recording, you can pass this recording along to somebody else, and as long as they have RR and Delve installed on their system, they can then debug that same recording that you were looking at and see the exact same sequence of events that you saw. And this is just a useful way of, like, instead of jumping on like a call and having somebody watch you go through a debug session or something like that, you can describe the problem to a colleague, send them the recording, and maybe they can start digging into it themselves. Just a really, really cool kind of feature. So I'll show how to use it. It's super, super simple. So again, we're going to use the debug command. And all we're going to do is we're going to add this extra flag, and we're going to say Delve Debug with the RR backend. And then we're going to say command Podman once again. And what this is going to do is, you see immediately we have a lot of input here. So what it does is it runs the command to completion, and then it records the execution of that, and then it starts you in a debug session where you're debugging the recording. So now we're not actually debugging the live program as it's running for the first time. We're debugging the recording of what we just did. So again, if we continue to main again, we see, that the debug session is kind of as we expect it to be. But there's some interesting things that we can do. Now, if there were any like sources of non-determinism, like if we were to print out in this program the current time, you would see every time we rerun this recording, the time output is going to be the same. If we read from dev random, the output of the bytes that we get back is going to be the same every single time. So we really are just debugging a recording. Everything is going to be the same every single time. And since we're debugging a recording, we can also do some really interesting stuff. So while you're in the context of a recording, you can actually do like reverse execution. So I can say reverse. So if I prefix a command with rev, I can say rev next, and I'm actually going backwards in time. You can see next, I'm going forward, rev next, I'm going backwards. So this is really cool for like if you've gone past where the bug is and you want to back up a little bit and kind of replay and re-examine a series of the program steps or something like that. This is a really cool way to do it. And then, like I said, every time once you restart or anything like that, you're just restarting the recording, so everything is going to be the same every single time. And let me show one other thing real quick. Let me see. I'm trying to show. Right. So you can also see where this trace was saved. So like I said, if you're debugging something and you have a recording of it, as we do now, this is where that recording is stored. So for me in this container, it's being stored at root.local share rr debug bin 0, right? So this is the file that you could take and hand off to a colleague or use in the future if you wanted to go back and debug a recording. And if you have a recording, you can use the replay command to replay this trace, right? So if like a colleague gives you a recording and you want to debug it, you can use the replay command to debug it. Or if you have an old recording and you want to pick back up where you left off, you can use this subcommand to debug a recording. So that's kind of some of the basics and some of the cool stuff that I wanted to kind of show off initially. We have like a little over 15 minutes left in the time that we had slotted for this call. So I kind of wanted to take a second and like see if folks on the call have any questions. Maybe there's something else that you want to see that I can show, or any other questions that I can answer while I'm here. So I'll kind of open the floor a little bit right now for like, what do people want to learn more about? What questions do you have? Anything like that. And I did see that there was a question about some Starlark examples. So let me do something real quick. I'll paste something in the chat. So there's a couple really cool things about Delve. So we have a full like JSON RPC API. So the way that Delve actually works is it's by default like a client server setup. So there's a debug server and then a client that connects to it. So even when you type Delve debug, it's doing that setup under the hood. But it's really cool because the server exports JSON RPC API. So you can also programmatically control Delve if you wanted to. I can give some information on that. But if you wanted to write like your own client, or even if you just wanted to write like a small program to basically script Delve or something like that, there's you can use the API to interact with it programmatically, which I think is really cool. But since there was a question specifically about Starlark, I'm going to paste this in the chat. So we have a ton of documentation on Starlark. So for those who aren't familiar, Delve also has the ability where you can write programs and script the debugger from within, essentially, right? So you can create your own commands using this Starlark scripting language. And Starlark is basically like a dialect of Python with some limitations. So you can basically use this like Python dialect to write your own Delve commands or do all kinds of really interesting stuff. So if you take a look at that that link that I pasted in the chat, there's examples of Starlark commands that you can write and that you can use and stuff like that. One of the coolest examples that's in that piece of documentation is actually there's a script to take advantage of the RR record replay backend. And the script basically will say like, rerun this program every time until you hit a specific condition. Once you hit that condition, stop. And you're rerunning it with recording. So kind of going back to what I was talking about before, if you have a bug that only exhibits itself like 1 out of every 50 runs, instead of manually rerunning it every single time and trying to capture that recording, again, let the computer do the work for you. You can write a quick little Starlark script that will continue re-recording the program until you hit a specific bug and stop there. So you can write this script, load it into the debugger, execute it, go grab some coffee or whatever, and then hopefully by the time you get back, you'll have caught the bug and you'll have a recording of it that you can then always go back to, and so on and so forth. And the reason why I mentioned the JSON RPC first is because everything that you can do through the JSON RPC API, you can do through the Starlark scripting interface. So it's extremely powerful. Like for reference, the JSON RPC API is how the Delve CLI client communicates with the Delve debug server. So anything that you can do with Delve, basically, you can do through both the JSON RPC interface and the Starlark interface. So it's really, really powerful. You can really create like your own complex commands or scripts or anything like that. There's really a lot of power there. So I would definitely encourage folks to take a look at that documentation. If you're interested, like write a few kind of like interesting little scripts or whatever, and test it out, and just kind of know that you have that in the back of your head whenever you need to use it. So Delve can also source like its own commands. So if you had a file that was like if we were to do something like I don't know if I have V here, but let's say we have this little script here. We could do Delve Debug init file equals commands.txt, and then command podman, or maybe it's just init. Yeah, init. Sorry. Init. So this init flag takes an initialization file. So there's two ways to do this. So if you're starting a session from scratch, you can use --init and pass it like a text file that has command like valid delve commands in it, and then it'll run those commands right on program startup. This is also kind of cool for like if you're starting and stopping debug sessions a lot, but there's like a consistent set of things that you always do when you start the session. You can codify them in a file, and then that way you can save yourself a lot of typing. So if we start this session, you should see like we've already it's already setting a breakpoint for us because we told it to in that file. It's already continued. We've stepped, we've done next a couple times, and then we've tried to print out any locals that we have, and there aren't any at this particular point in the program. But this is just a cool way, like I said, of like executing a bunch of like delve commands right as you start up or something like that. You can also source them from within. So if I were to do like source commands.txt, it'll kind of do the same thing. And it's trying to execute these commands, but we're already way past the point in the program where we should be executing these commands. So that's why we're getting some errors. But I just wanted to show that that's possible. So yeah, any other questions or anything?
Yep, I have quite a few, but I'll let the team, if they have something in front of them. All right. Can you tell us what you said it was the RR package? What is it that you actually install? Is it an RPM, or do you go get it from somewhere upstream?
So if you're on Fedora, you should be able to just DNF install RR, and then you can get it from the package that way. So it's already installed in this the container that I'm in, so it's already there. Yeah, but so if you're on Fedora, just DNF install RR. It's also super easy to build from source. So if you wanted to do it that way, you can go. It's Mozilla RR. So I can send a link to where it is on GitHub. But here's a link to that project. And yeah, it's really easy to build from source. It's also, there's RPMs for it. I believe it's also packaged for RHEL as well as Fedora. So it should be pretty easy to get.
One of the other things that John and I always have to fight to remember is how to inject build tags. And if you do a make podman -remote, you can control C it right away. But if you do that, you'll see that one has a set of build tags right there. You can kill it if you want. But
yeah.
You see all those?
Yeah.
So if we wanted to, that's our remote client. So if we want to debug our remote client, we have to pass those tags, and that can really get us sometimes.
So if you need to do that through Delve, you can pass -- build flags. So this will tell Delve while you're compiling the program, also include these flags during the Go compiler invocation. So you could say -- build flags and then supply this flag, which would be the tags that you need to be able to build that binary.
Is there any way to put that in some kind of configuration file?
So Delve does have some global configuration, but this isn't one of the. This is not one of the configurations that you can just put in a config file or anything like that. Unfortunately, you would need to specify this flag, but it could be cool to have maybe. I've been thinking about this for a while to set up some sort of local config for Delve, where maybe you can set different contexts, right? Like I want to debug within the remote context, and it'll automatically pass along these build tags for you or something like that. But right now, there's not a way to do that.
Okay, that would be sweet, because I end up a lot of times with 2 Delve sessions, one running the server side of Podman and one running a client remote side.
Okay.
So I have 2 windows open, both running Delve. So if you do something with the contexts, that would be super helpful. Also, if the prompt could show what context you were in.
Okay. Yeah, absolutely. I mean, I think that's a really cool feature, and I can already see a ton of use cases for it. So yeah, that could be something really interesting to work on. I'm actually kind of excited to hack on that. This is really
cool. Yeah, because that was kind of the reason I was asking about Starlark, is just how abusive could I get in there?
Yeah.
Because setting up those 2 environments sometimes and getting them right, halfway through debugging, I realize, oh, I got the wrong tags or this or that, and I have to start over.
Right. Yeah, absolutely. And then so there's also as we saw, there's also the rebuild command. So if I'm not mistaken, I think the rebuild command you can pass along build flags as well. So if you are in that situation, if you didn't want to exit the debug session, you could rebuild and modify the flags and stuff like that. But it's just one step away from exiting and redoing a session or something like that. So, but just a small convenience.
On the rebuild, if you edit the code and you do rebuild, is it going to pick that up?
Yes.
So that's an ideal workflow, I guess. Yeah.
Yeah.
Okay.
So that's another thing too. And when I do some of these longer form sessions and trainings and workshops and stuff, that's one of the things that I show, where it's so oftentimes if I'm iterating on a problem, I'll have a terminal open that just has a long running Delve session, and then I'll do whatever I need to do, jump back to the code, make some changes, do a rebuild within that session, and then just keep going. And I'm not losing out any context or anything like that, or whatever. It's just also just kind of a nice convenience.
Yeah, I leverage rebuild a lot. I didn't realize that it took options, so I'll look at that.
I got a couple questions more yet. Can you show? You probably don't want to exit your container, but before you leave, can you show Vim with the debugger?
Yeah, I'm a very, 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 very long time Vim user who has recently kind of made. I hop between IDEs all the time, but I'm mostly in VS Code right now for the most part. So I don't know if I have a fully set up Vim.
How about VS Code?
Yeah, I could probably do it.
Show that, but
yeah, I could probably do it through VS Code.
Let's do that last, if you don't mind.
Yeah.
The one thing I talked to you about that I've never really been able to get working successfully is it's not on you're debugging, but you're not on your laptop where all your tools are. You pull in Delve, and let's say it's a RHEL system. Delve is way more helpful when it has source code to look at, right?
Yeah.
How do you do that with a package like that in RHEL? And you don't have to use Podman as an example, but that's the one we use. Can you walk us through that?
Yeah, so you're talking specifically about like when you're trying to debug something and you don't have the source code?
When you're trying to debug something and it's, say, a vanilla rel server, and you need to go get, is it that binary is optimized, so do you need to go get the debug info and then install? Is that enough?
So even with an optimized binary, the debug information will still be there. If the debug information has been intentionally stripped, Delve is able to open up external debug information. It looks for it in some well-known locations. I believe I haven't had to do it in a long time, but I believe there's also an option where you can kind of tell Delve like where to search for external debug information. So you can use Delve with stripped binaries as long as like if the binary is totally stripped, like all the dwarf and information has been stripped out. If you have that externally, you can still use that. But so something else that could be useful for the source code problem. So like say that like this is a common situation and something that I talk about a lot in workshops and stuff where like say you have like a program running in like a Scratch container. Like there's nothing there, just the process that you're debugging. There's a couple ways to do it. You can do it remote, where you start a headless debug server within the Scratch container, and then you connect to it from outside, and then you have the source code there. But like, so let me show something real quick that might help illustrate this point. So when you start a debug session, you can do sources, which will show all of the source code that went into building your program, right? So here, my go root is userlib Golang, and if I do like sources main.go or something like that, you have Podman command Podman main.go, and it's like that because this has been built within a container. So say you have like a common situation where you have like a multi-stage container build, right? Where maybe you start with like a rel 8 base image or something like that as your builder. You compile your Go program and then you copy that into a Scratch container. So by the time you get to the Scratch container, the original path of the compilation is not going to be there anymore, like this /podman or whatever, and then your source code isn't going to be there. There's a configuration that you can do where so you can change Delve configuration at runtime. So if you're in a situation where you're debugging an app and the source code isn't where it was when it was originally compiled, like maybe you're on this rel server and you have to like clone down the source code or something like that, right? You can do config substitute path, and it's from to, right? So you can say anytime you see like in this last example, anytime you see like /podman blah 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 blah, right? Replace that with home, my user, code, podman, source, or whatever. So this will tell Delve anytime you see this source or this path when you try to print out like where you are in the source code, actually look for it here. So if you're able to like clone down the source code, you can use this substitute path configuration to say the source code lives over here on disk. So look for it in this location when you print it out. And then you can get back to doing source level debugging. Does that make sense?
Yep.
Awesome. And then
and what the remote sessions are, they is it just straight TCP?
Yeah, it's a TCP session. There's no like TLS or I don't know. Sorry if you can hear some screaming in the background. My children are losing their minds for some reason. So there's no like TLS or any kind of encryption over that TCP socket connection. So I recommend a few things. If you're doing local, what I like to call like local remote debugging, where you have like a headless server within a container, and then you're just connecting to it from outside of that set of namespaces and stuff, then you don't really have to worry about it a lot. But if you're doing remote debugging into like a Kubernetes cluster, or you're on your laptop and like you have all, like, say you have all of the source code and all of that stuff on your laptop, but you want to debug an application running on a remote server. What I would do is I would pair this substitute path configuration with an SSH tunnel. So use an SSH tunnel to create the connection between your laptop and the remote server, and then do like, port forwarding. So forward the port of the Delve headless server through this SSH tunnel, and then connect the Delve client using the SSH tunnel. That way that the communication between the Delve client and the server is encrypted. And that's a safe way to do like remote debugging. And then in that scenario, if you already have the source code on your laptop, you don't have to like clone it onto the server or anything like that. You can still use this substitution path configuration to do the step source code level debugging and really easily.
Others?
I'm sorry.
It's like, I was just seeing if anyone had other questions as well.
Yeah,
I think I could ask it. I could ask another hour's worth.
Yeah, I'm happy to, stay on, and if anybody has questions, like, anything really, I'm happy to dig into whatever.
Hey, you want to show us VS Code?
Yeah, let me see if I can get an example of that going real quick. So, let's see here. Let me see if I can go. So it all happens through this launch launch.json file. So you have an extension Docker file. Okay, whatever. So I don't want to do that. Let me open up get it someplace useful. So let's go the main package here. And then you're going to go over to this run and debug, click this, and it's going to start like trying to create like a debug session. And it's gonna complain on my system because this was one of the reasons why I wanted to debug in a container, because I didn't want to install the dependencies on my system to build Podman.
Understandable.
So if I had all the dependencies, it would do basically what I showed at the command line, right? Where it would do the Delve debug, and do all that. Now let me see.
I know for John and I use Golang quite a bit.
Okay, same thing there.
It is, and there's this on the run and debug. There's a dialog there where you can put in build tags that allow you to, for example, if you put those build tags in that we talked about, we showed you earlier, you wouldn't need any dependencies. But that's how you get around it.
Okay, I see.
And I think in the case of IDEs as well, when at least on Golang, when you use the debugger, you have to provide the program arguments to it as well. Okay. Unlike, it's not a true Delve session like you were showing, so where you can do add that stuff in later.
Right. Yeah, I don't know through the IDE if you can like issue like a rebuild command or something like that. I usually use Delve through the CLI just because that's where I'm most familiar.
Yep.
But the integration through like Golang and VS Code and Vim and all of that stuff has gotten really, really good. So typically a lot of the stuff you can do in the CLI, you can do in this as well. But it's kind of the same with VS Code, where you can kind of like you can create these launch configurations. So this could actually be something that's helpful for like, excuse me, what we were talking about earlier with like the contexts, right? So if you're debugging with an IDE, you can set up these different launch configurations, and then you can essentially have these different contexts codified through your IDE, as opposed to being directly supported by Delve, right? So you can imagine where this is like launch server, right? And then you had another configuration that was like, launch client, and then you change like different aspects about how the debugger is launched, and different arguments that you provide to it and stuff like that. So that could be like an interesting way before like this feature lands in Delve, because I still think it's a cool feature for just the CLI, where you could have these kind of different contexts through your IDE. And then I know like with VS Code, you can just do it this way, right? Where you can do launch server, launch client. It doesn't really help, I don't think, with like having two running simultaneously. So your mileage may vary there. That's where it might still be cool to have the context from the CLI, where you can have like, you can like split your terminal or something like that and have two running side by side. Yes, I see there's a hand raised. Go ahead and ask.
I had a question regarding the watch command and the RR command. I was trying to read the doc, so I was specifically looking for the scenarios where the bugs are triggered because of the processes are running in parallel, or like they run together, like not watching a single process, but rather than watching multiple process. And to be able to watch a file or object on a file system, would that be possible using RR or the watch instruction in the debugger? So typically something like if you launch 10 Podman process in a loop and just record the one that broke for a particular command. So I'm just, yeah, sorry.
So this is, just to be clear, this is distinct from trying to debug a process tree, right? You're not talking about trying to debug a process tree. You're talking about like trying to cut the, so like optimizing the time to find the bug, right? Like running 10 Podman commands and seeing which one hits the bug. Is that what you're kind of saying?
Yeah. It's like, for example, I run Podman help, but I would rather want them to be triggered in parallel, and I want the RR to be able to record the one which specifically failed for the command. So I'm just trying to read the docs, but I'm not able to exactly look for what I'm trying to look for.
So what I would recommend in that case would be is to use kind of like the Starlark script that I mentioned before, to just have your computer rerun the program for you until it hits the bug, re-recording it every time. If you wanted to do it like the way that you're describing, you could write like a shell script that like forks 10 times and calls RR record with the Podman thing. And then if you notice any one of those hitting the bug that you're describing, you can see through the RR output like where it's saving that trace to, and you can replay that trace. So you'll always have that the trace, the recording of that execution that you can go back and replay, even if you like fork 10 processes and record them all. But you would have to record them all individually. Like there's no way to tell like Delve or RR, like, I want you to fork 10 versions of this, record them all simultaneously, and then only give me back a recording for the one that failed. You might be able to do that programmatically somehow, but by default, that's not supported. So what I would recommend is using the Starlark scripting interface to do kind of what I mentioned earlier, like just have the computer rerun that program for you, go get some coffee, and then write in the script, write in some sort of exit condition to where you know that you've hit the bug, and then you'll end up with that recording of the bug that you can just go back and replay and all that stuff.
Got it.
And then for the watch command, the watch command is more like if so if we do help watch, so it's more like you want to see like what I was talking about before, like you have maybe like a variable that gets changed or something like that, and you want to figure out where it gets modified, where it gets mutated, and you're not sure. You can do watch -w and then an expression. So I wonder if I can like show an example of this. Maybe if I do something like watch reexec or watch dash r reexec reexec. Okay, so because that's just a package name, right? Okay, so what if I do like watch write root command? Okay, so what I've done is I've set a watch point on this variable root command, and I'm saying I want to stop the program anytime that this variable is written to. So theoretically, if everything goes right, we should stop here on line 38 because that's where we're assigning to root command. So if I continue, you see I didn't explicitly set a breakpoint here. I just said I just want to watch anytime that the value of this variable is written to, and the debugger has done the work for us, right? So you can see we hit this watch point on this variable, and it'll tell us where we are. So this output also comes from breakpoints as well. I'm going on a little bit of a digression here, but so anytime you hit a watch point or a breakpoint, Delve will tell you how many times that breakpoint has been hit, and specifically how many times it's been hit by a specific Go routine. So our context is in Go routine 1, and Go routine 1 has hit this breakpoint 1 time for a total hit of 1 time of all of the Go routines, right? So it's just kind of interesting metadata about it. And if you wanted to see, I didn't really show this earlier, but if you wanted to see all of the Go routines that are running, use the Go routines command, and Delve will show you which Go routine you're currently on, what thread it's executing on, and it'll also give you some information about the Go routine, like what it's doing, where it's at, like what, you can see at the end, like some status of the Go routine. And right here, you see it says user. So by default, Delve tries to show you the information that should be most pertinent to you. So this is showing like the first area of code in user space, which is like non-private runtime. You can, if you do help Go routines, you can see there's a bunch of different ways that you can modify this command. So you can change where, like you can change some of the information that it shows for each Go routine and stuff like that. You can also filter and group Go routines. So if you're running, like you have 1,000 Go routines running in your process, obviously if you just type Go routines, it's going to be a mess. Like there's going to be so much output. But if you wanted to group them by like location, or you can also set you can also like tag Go routines and stuff like that. So you can also filter them by like tags and stuff. There's a ton of stuff that you can do. So I would encourage anybody to kind of like dig into the help output. And if you're curious about a command, just type help and then that command, and then there will be like detailed help output about it.
Anything else?
One thing like like we have watch for the variables. Like, do we have something like watch but for like syscalls? If like where a particular syscall, for example, I'm talking about the scenarios where a write call is triggered, but I actually want to, without skimming the code, would it be possible to just get the point from where the syscall is being triggered? Although I think that is possible via the tools like eBPF or something like that. But
like you just want to know that something happened, but you don't necessarily want to stop
Yeah, I just want to know, like, for example, something is written on my file system by process X, but what is the like exact code point where this happened in my source code?
Yeah, so you could do something like I would maybe use like a trace point for that. So you can say trace main and then continue, and then here if you go back through, you see you get like some trace point output of like the output is kind of noisy of this just in general, but this is the output of like a trace point. So you can say like go routine 1, hit this, and then you can also do stuff like maybe you can't do it from here. So you could do something interesting where you could say like if you do like breakpoints, right? You can say like on 4, which is the trace point that we set at main. You could do like on 4 stack, and then if I restart the program, it should put everything in there. So now when I do continue, you can see we hit this trace point, but we assigned behavior to it. So we said anytime you hit this trace point, run this command. And what it did is it ran the stack trace command. So you can see, the stack gets like output automatically sometimes, but that's why there's kind of like duplication of stuff. But you can see like every time you hit this trace point, you can get the stack trace of what led up to that trace point. So that might be a little bit more helpful. And then you can assign all kinds of behavior to trace points and breakpoints and stuff like that. So if you wanted to ask those types of questions, I would say set a trace point and then set like some behavior using the on command. And then that should get you where you want to be. Does that answer your question?
Yeah, that is helpful. Probably I think we'll need to do more stack traces and see like if we are getting the exact output which can be used. But yeah, this is something worth a try.
Okay. And then like if you have any more questions, like I'm around, so anybody can feel free to ping me like on Google Meet, or that's usually where I'm at, or Slack. I'm not hanging out on IRC as much, but like email or whatever. If you have a question about Delve or a particular debugging technique, or if something's possible or whatever, I'm happy to answer questions even after this call, whenever. Yeah, totally happy to help out. Cool. Anything else from anybody?
Thank you very much, and for your extra time here as well. And I found it very useful, even though I use the debugger. I use about 2% of it, so this really helped.
Awesome.
Thank you for your time.
Yeah, absolutely. Thanks, everybody.
Thank you.
Yep.
Thanks.
Thanks, Eric.